Siemens has developed a showcase to demonstrate how the industrial metaverse can help manufacturers collaborate and work in the future. In collaboration with Freyr, a Norwegian clean battery producer, Siemens developed an industrial metaverse experience based on their first Freyr Gigafactory. The process began with importing physical and digital data sources to the Siemens Accelerator platform and leveraging IoT TwinMaker from AWS and the NVIDIA Omniverse to create this accelerator industrial metaverse experience. There are many ways for Freyr to use this industrial metaverse experience. In the first example, Freyr executives use the industrial metaverse to sell a plant to prospective investors, giving them confidence in the proposed design through the ability to interact with a fully functional operational model of the plant. Users can browse the location and status of plants across the globe at different levels of construction. Operationally, key KPIs and information are displayed for each plant. For example, when the Giga Arctic factory in Norway is selected, it is easy to see greater detail about the plant, including geographic information and the surrounding terrain. This is a fly-through of the plant, starting in the material bay. Slurry mixing. This is the most critical process area. Each of these assets is connected to the digital twin, so all aspects of the equipment can be simulated. Key information, including critical KPIs, real-time series data, issues, service history, and requests, are available for each piece of equipment. This includes the ability to look at OEE information to understand current operational performance, availability, and quality, as well as to understand the overall performance or make predictions about future performance. The Quality Prediction Hub allows production managers, quality and manufacturing engineers, and operators to better understand the complex relationship between production machine parameters and the resulting product quality. With real-time input of actual manufacturing parameters, we can apply machine learning techniques to automatically predict resulting product quality characteristics before a defect and quality loss occurs. Mixing is a critical process, so leveraging the digital twin to optimize all aspects is essential. This high-fidelity simulation of the laminar and particle flow of the mixing process is leveraged to optimize the stirring process. In the Industrial Metaverse Showcase, we can engage with any asset to understand the operational performance or what process it may be performing. This robot, like any asset, includes many data sources as part of its digital twin. This can be used to dive into the performance of the main control drives, identifying anomalies and service requests, or schedule maintenance. This showcase demonstrates how in the industrial metaverse, users will be able to make the best engineering decisions because of precise, accurate, up-to-date information. For example, a service engineer may want to understand the detailed digital design information for this robot, including the bill of materials and detailed 3D design information. In the industrial metaverse, this can be explored not only from a mechanical perspective, but also electrical and software, even down to the tolerances of the machine. This is an emergency backup generator. The Energy Manager dashboard allows quick access to generator metrics, the overall share of the generator to the whole factory consumption, as well as telemetry information about its condition. The flowcharts depict the energy flow across the factory and from the share of supply to the individual departments. It is clear where most of the resources in the plant are being consumed. The Energy Media reports enable users to better understand what resources, over time, are being used by equipment in financial terms or CO2 equivalents. Passing through the aging area, onto where the battery packs will be assembled. This area was added by Siemens for demonstration purposes, as Freyr has not yet finalized this area. The digital twin drives the precise orchestration of each robot, each cell, and also how they interact in harmony across the entire line. Digital twin behavioral models are not restricted to just machines and processes, but can also be used to optimize and validate human interactions and processes. And these can be used to simulate or optimize for safety or performance. Using true physics-based human models to optimize tasks and working environments enables use for training and documentation. Siemens is excited about the potential for the industrial metaverse to improve how we design, collaborate, and manufacture products.